together.
Good morning, guys. We are going to continue working on the triple integral. Let us do this one, and then you have plenty of examples. When you do the work, if you get stuck, let me know, and I will help you. Then after I show you this example, how to set up the integral and so on, and evaluate this, I think you will be in a good shape working with triple integral in Cartesian coordinate system. But all integrals, as you know, are not easy in rectangular coordinate system or Cartesian coordinate system. So we have to look for first double integral in polar coordinate, what it looks like. Then tomorrow we are going to work on triple integral in cylindrical and spherical coordinates. All right, does it sound okay?
Sounds good.
All right, so let's do this one. Please draw the picture, take your time, and I will spend time on this, because if you understand this one setup, then you can understand the others, and you can easily work it out independently. So that is my intention. Instead of giving you plenty of examples, really walking you through with one example with a better understanding will help us. Sorry, I'm back and it kicked me out. Thank you for waiting patiently. It happens once in a while. In any class also, when this happens, just stay until we exhaust our options. Okay, so can you hear me well, guys? Or is it spotty, my voice?
I can hear you.
Okay, so the first thing first, let us draw the region. So you have to have really a clear idea what is going on. So in this case, what we have to do is, let us draw the graph 4 minus x squared minus y squared. So it is going to be, and it is in the first quadrant. So 1, 2, and 1, 2 are going to be the intercept. And here the z is going to be 1, 2, 3, 4. So technically, okay, we have this kind really solid coming out. I'm just drawing because x is greater than 0, y is greater than 0, z is greater than 0. I didn't continue to draw the other side. And also the paraboloid, the region that we have, the x, z equals x squared plus 3y squared. Then what happens is, you are going to have a parabola which is really going this way on the x direction. Okay, on the y direction it will be a little bit skinnier because 3 times that coefficient that you have. So let us put it this way. And then now what happens is we are going to have this solid. Okay. Okay, makes sense, guys? And now, what is really happening? We need to find out the intersection of this region. This. And when you project it, that projection will come over here. So to find the intersection, what we are going to do is let z equals 4 minus x squared minus y squared equals the other z, x squared plus 3y squared is equal to z. Z equals z. That is what I'm doing. So I'm going to really take these two equations and solve them. So what I'm going to do is, let me bring this 4 equals 2x squared plus 4y squared. And then let us really solve. That means x squared plus 2y squared is equal to 2. And what is really this looks like? So we want to draw, let us divide both sides by 2. So x squared over 2 plus y squared is equal to 1. Okay, definitely this is really ellipse, but it is bounded by the first quadrant. That is what we have in the first quadrant. So this will help me actually to decide now what to do. Well, because the function is really x, so it is better to deal with this simple. So therefore, my domain D equals the ordered pair x and y. And then now, actually also z. Z is changing also. I'm going to put such a way. Well, when I project that one, x is changing from 0 up to this point, which is 1. What we have to do is, so x is changing from 0 up to 1, and y is actually y is changing, and then y, because it is x simple, and x is changing from where? Well, if you look at here, x squared is equal to 2 minus 2y squared. So x is equal to square root of 2 minus 2y squared. That's it. So it is from 0 because that is a quadrant we need, and to what? 2 minus 2y squared. Well, how about z? Z is changing from the lower function. That is what we are going to do. This parabola to the top, that is the intersection, the upper function. That means z is changing. The upper is the circular paraboloid, which is 4 minus x squared minus y squared. And the lower is this one, again, the other paraboloid, which is x squared. Z is equal to x squared plus 3y squared. Okay, I have this. And then now, what we are going to do is the integral w of x times dv is going to be changed into the first has to be the constant boundary. That means from 0 up to 1. And then the second one is, which is really containing only one variable, the outer one. The outer variable is going to be y. Therefore, integral from 0 up to 2 minus 2y squared. And the innermost is going to be actually z is changing from x squared plus 3y squared and 2 4 minus x squared minus y squared. And then I have here x. Then the innermost is dz. The middle one is dx. And the outermost is dy. And that's it. This is how we are going to set up the volume. So technically what we are doing is actually the volume which is bounded by this dome, the x-axis and the xy plane and yz plane, and here also are bounding it. So it is this kind. In other words, you draw it. I'm sorry, let me try to draw. Something like this, solid. That is what we are going to really calculate. Okay, is the setup clear, guys? All right, so let me recap. What we are going to do is first you draw the region, and then now what we are going to do is, okay, what is actually bounding it? This domain has to be determined. So to do that, the two surfaces, this and this surface, they have intersection. And that is it. When you project it, your integration is going to be limited by that. And that is what is really happening. And then what you are going to do is, when you really project on that, these two has to be equal. And this will give us how is the z value, the x and y value are changing. They are related by, when you project this one, they are related by these equations. So when you do that, you can really determine how x is changing because I picked the for x simple. If I make it y, it will be solving for y. It is also possible, but that makes it a little bit challenging because you have to divide it and so on. So this is really simple, and because it is in the first quadrant, I don't have to take the minus, only the positive one, and I have that boundary how x is changing. While x is this much, what is the y value? Well, by making x is equal to 0, when x is 0, 2 equals to y squared, y is equal to plus or minus 1. Then it is in the first quadrant, it is changing from 0 up to 1. That is what we get. X is changing from this, and we set up. Okay, once we finish the setup, how it is really done, then we are going to evaluate the integral, which is not really that bad. Okay, so I have x times z integrated, evaluated from x squared plus 3y squared up to 4 minus x squared minus y squared, and you have dx dy. So when we plug that, that is integral from 0 up to 1, from 0 up to square root of 2 minus 2y squared, and x times 4 minus x squared minus y squared minus x times x squared plus 3y squared. And this is going to be evaluated with respect to x and then with respect to y. All right, so when I do that, actually I'm going to have, okay, let me clean up this one and I will copy it other. Okay, 4x and minus x cubed minus xy squared, and then minus x cubed minus 3xy squared, and this is going to be evaluated from 0 up to 1. Okay, so let me collect like terms. 4x squared I have 2x cubed y, and here these are. So when I am combining them from 0 up to 1, from 0 up to square root of 2 minus 2y squared. Okay, 4x doesn't have any friend by itself, but this x cubed and this x cubed, it will be 2x cubed, but that is negative. And then I have negative 3xy and y squared, and this xy squared, so negative 4xy squared, and that is dx dy. Okay. Then now what we need to do is, okay, let me copy the question here. Integral from 0 up to 1, integral from 0 up to 2 minus 2y squared and the radical, and 4x minus 2x cubed minus 4xy squared dx. Just I'm copying it, so we have to follow. You already have this one, guys. That's why I'm lifting it. Yes?
I'm following.
Okay. So now let us actually integrate with respect to x. Integral from 0 up to 1, and then this is going to be 2x squared minus 1 over 2x to the fourth power minus 2x squared y squared evaluated from 0 up to square root of 2 minus 2y squared, and that is dy. Okay, then now we can really plug this value, and when we plug that value, integral from 0 up to 1, all right, the power of square will really eliminate that radical, and minus 1 over 2, and that is actually 2 minus 2y squared the whole square, because 4 and this radical, so it's a power of 2, and then minus 2 times 2 minus 2y squared. And this, the whole thing is going to be integrated with respect to y. Because when I put 0, this is going to be 0. This is everywhere. It is going to be 0. That's why the lower limit. Is that clear so far?
Yes.
Okay. Then this is really very simple. 4, I have minus 4y squared minus 1 plus, actually, hold on. Let me expand this one. It's better. Let me leave it as it is. Bear with me. Negative 1/2. And when this is 4. 2 times 2, 4. 4 times 2 is 8. Plus 4y squared. Y squared is the whole squared, y to the 4th power. And then minus 4 plus 4y squared. Yeah, we have to be careful this evaluation. Okay, integral from 0 to 1, 4 minus 4y squared. Well, actually, this positive 4y squared and negative 4y squared, this will be cancelled. And this 4 and this 4 will be also cancelled. That's fine, it's gone. Therefore, I have to deal with this. Actually, then what is really happening? Negative 1/2 I have times 4 is negative 2. And negative will make it positive. Positive 4y squared.
I think you're missing a y squared.
Which one?
In that top line, the last term.
Here?
Yeah, that should be a 2y squared times 2 minus 2y squared. Am I?
Oh, I forget. Thank you.
Yeah.
Thank you. I forget my y squared. Yeah. Then actually, all right. Yes, I forget my y squared. Thank you. Otherwise, actually, when the answer is not really matching, I will be really surprised. Thank you for paying attention. Okay, let us really copy this one. I have 4 and minus 4y squared and minus 1 over 2 and 4 minus 8y squared plus 4y to the 4th power. So far, I am okay, yes? And now, when I copy this one, I have negative 4 times y squared, and this one will give me positive y to 4y to the 4th power. All right, and this is dy. Okay, 4. By the way, this and this still cancelled, yes? No, this is negative, this is negative. Both are actually surviving. I'm sorry, I'll take it back. 4 minus 8y squared, these two, the one I crossed out, plus 4y to the 4th power. And then when I multiply this, negative 2 and positive 4y squared minus 2y to the 4th power, and this is going to be evaluated with dy. Okay, I have, let me clean up. 4 and 2, these two will give me 2. Sorry guys. I'm sorry, somebody is really disturbing me. Hold on. Okay, back. Sorry about that, guys. Okay, this will give me 2. And now let us compare the square terms. And I have negative 4y squared and this is to the fourth power, and this also to the fourth power, so this is 2y to the fourth power, and evaluate the y. All right, so I have 2y minus 4 over 3 y cubed plus 2 over 5 y to the fifth power. And that is it. We have 3 terms. So what we are going to do is 2 and minus 4 over 3 plus 2 over 5. And that is what we are going to recall. The least common denominator is really 15. And then what happened? 15 times 2 is 30. And this is 5 times 4 is 20. And then 3 times 2 is 6. So 16 over 15. I think that is really what we need to get. Is it clear, guys? All right. So this is really how you set up the volume. And look, triple integral, it's a lot. And by the way, although I messed up here, but look, almost 2 pages. So be careful, especially when you have some constant coefficients and when you are collecting like terms and so on, you will not be immune from making error. And my concentration was looking at also on the people who are coming on the wait list in the waiting room, and at the same time I get distracted and I forget actually that y square, and if you didn't detect me, it could go wrong. All right, so the triple integral is 16 over 5, we get that. Now the other thing that I want to learn in triple integral is the average value of a function. F average for a single variable. It is 1 over b minus a integral from a to b f of x dx. And F average, this is, okay, thank you. And that is for a double integral 1 over a, and this is going to be region R of f of xy dA. And now F average on volume, actually what you are going to do is A of R, by the way, and that is X, Y, and Z. Then this is going to be 1 over V of the domain W and integral, triple integral over W, F of X, Y, Z, and this is going to be dV. Okay, the reason I'm giving you this is the connection. So in this case, what do? To get the average value, you take the area under the curve and divided by that interval, 1 over that interval, or multiplied by 1 over that interval, or divided by that interval. And when you are finding the average value of a double integral that you learned already, the double integral dA, and you multiplied by 1 over the area of that region, and the average value for actually triple integral will be the same analogy, 1 over the volume of within that solid W multiplied by the integral, the triple integral of that. All right, and this volume V of W is what? By the way, how do I calculate? Somebody will say, well, it is actually W. The density function is going to be 1 and dV. That is what we are going to do. Is it clear? The density via function is 1, the integrand. Then dv is going to be giving you v. So that is how you are going to get actually v of w. All right. If you have any question, I will answer. Otherwise, we will go to actually double integral in polar coordinate system. That's it. Okay, shall we do one more setup? You said? Okay. Okay. All right. That is great. And actually, yeah, guys, feel free to ask me questions like this, and that is the whole purpose. Instead of me lecturing in stone where you don't feel comfortable, yeah, feel free to ask me. Okay, let me come up with one problem. All right. Okay. Okay, yesterday I gave you with tetrahedron. Am I right? As example. I don't want to repeat myself. Yes? Yeah. All right. Then we did the intersection. Now just let me give you one solid. And then let's set up. And what I'm going to do is I will give you actually 1 or 2 minutes so you can really process it. And then we will do the setup together. Is that okay? Okay. Find the volume V of the solid in the first octant that is enclosed by paraboloid well z equals 16 minus 4x squared minus y squared and the xy plane. And if this is not sufficient, feel free. Actually, I will do whatever it takes. We'll work together. All right. I can bring another problem also. So I don't have to go move forward until you feel comfortable, because this is really instrumental for me to talk about others later, because we are going to use them over and over. And before we move on, I want you to really feel comfortable. Okay, guys, did you think about it this much? And shall we do it together? One more time. Okay, let's do that. First, draw the region as I said, and then you'll see it clearly. Actually, on the other side, also the projection I'm supposed to draw it, I will draw this time. All right. So what is really happening is Z is 16. Let us mark that 16 point here. And it is not the intersection. Now we don't have to worry about it. But now on the Y direction, when X is 0, Y is square root of 4. I mean, the square root of 16, which is 4. This is 4. And it will come back this way. And then now, by making actually y is equal to 0, that means x is equal to 2. And we have this. And since it is in the first quadrant, this is what is really happening. So the region R is this. So let me draw the region R. The region R is when R is where Z is equal to 4x squared minus y squared is equal to 0. Then now 16 is equal to 4x squared plus y squared, and actually 1 equals x squared over 4 plus y squared over actually 16. So if you really where the y value is going to be 4 here, x value is going to be 2, and this is actually the region that I have. And this region is y is equal to square root of 16 minus 4x squared. If you want, you can really make it x simple, or you can make it also y simple, and we'll work with that. By the way, this is 4, this is 2, and this is the region we are going to integrate. Z is changing from this up to the 1. So let us write the domain. The domain D of this W is going to be the set of ordered triples X, Y, and Z. And now let us really see first on the region how is X changing. If I make it like this, how is X changing, guys? X change from here to here, and that is what?
0 to 2.
Okay, 0 is less than or equal to X less than or equal to 2. And then how is Y changing? From this all the way to the curve. Do you guys agree? Yes or no? Okay, 16 minus 4x squared. And now, how is Z changing? And if you allow me, let me write Z over here. And Z is changing from the XY plane, which is 0, up to the curve that is actually 16 minus 4x squared minus y squared. Make sense? Okay, then now let us really finish it. Then what did I say? I gave you, the reason I gave you this one is I don't want you to be puzzled. The volume is going to be what? The triple integral over W of dV, yes? That is where we are going to start with. Is it clear? Because I said volume, then you have to have the really concept. Then this one will change it into iterated triple integral, and the innermost is going to be this one because it has two variables, 16, I'm sorry, from 0 up to 16 minus 4x squared minus y squared, and then the middle is going to be with one variable, the outermost, which is from 0 up to the square root of 16 minus 4x squared. I'm sorry, I overcrowded. And then the outermost has to be the constant from 0 up to 2. And dV this time is going to be dz, then dy, and then dx. Okay? Okay, on the other hand, I can really also set up this equivalently. What I will do is, instead of y squared is equal to, what I can do is actually 4x squared is equal to 16 minus y squared, and then actually x squared is equal to 1 over 4 times 16 minus y squared, and then x equals plus or minus, but I will forget the minus because it is in the first quadrant, then square root of 16 minus y squared. And based on that, then my integral is going to be like this. Z will not change, but the domain this time of W. By the way, is it clear how I set up this one before I go to the second one? I was imagining that nobody asked me, so you understand with this, yes? Yeah. So let us move on and do the other one, because in both cases you are going to get the same result, Z. And this time, Y is changing from where to where? From 0 up to 4. And then x is changing from 0 up to 1/2 of the square root of 16 minus y squared. And z will remain the same. 16 minus 4x squared minus y squared. And based on this, then now what do? The volume. Okay, after I have this, let me put it so everybody can see it. V is going to be the integral over W, the solid region, dV, because the density function is 1 now this time. So this integral is from 0 up to 4. Integral from 0 up to actually 1/2 of the square root of 16 minus y squared. And then the integral from 0 up to 16 minus 4x squared minus y squared. And then this is dz. Then now what happened? This is the x changing. So dx and then dy. So these two will give you, no matter what, as long as you do it right, will give you the same volume. Does it help, guys? Yeah, the more we practice, the better will be it. And by the way, the double integral becomes natural is because you have seen it and you are seeing it for the second time. Yes. And remember, when you walked into that classroom and when you start double integral, at the very beginning, it was not really more intuitive. The more you see one or two, it clears up. And here also, it will clear up over time and you'll see it. And by the way, go ahead and do the not only the warm-up, actually the warm-up problem that doesn't give you that much because one or two, and the answer, also the setup and so on will not be. But do the actually the lecture note and even the textbook, the syllabus problems. And then if you get stuck, again, the whole purpose of this one is, this session is always to answer your question if possible. If not, what I'm going to do is I conduct seminar solving problems. I didn't prove that much theorem or something like that. What I show you is the nitty-gritty stuff of the problem solving tactic. Okay, I hope this helps, yes? All right, so tomorrow we are going to talk about, it's okay, by the way, don't feel that you guys are making me lag behind. No, I don't mind, actually. If it's not clear, stop me, just like you did today. So we'll catch up, don't worry. So tomorrow we are going to start polar coordinates. That will not take me that much because you already have the exposure. And then we'll work with cylindrical and spherical coordinates. Then we'll see some applications and that will do it. Then chapter 17, we'll talk about vector field, the flow of flux and scalar field. Then we'll talk about line integral in chapter 18. Then chapter 19, surface integral and actually what it looks like. And we'll talk about Gauss theorem, divergence theorem, Stokes theorem, what are their importance and so on, how these people are actually, these theorems are helpful in engineering, electricity and magnetism. And we'll see that. And that will be the flavor of this course. All right. All right. Thank you, guys. Take care. Bye.
Thank you.